So in this video, we're going to take a look at a very interesting phenomena called the Lenz effect. You can see that the can, we have an aluminum can here, and a strong magnet, they're really not attracted to each other. Have the can right next to the magnet, and the magnet's not being pulled towards the can. To demonstrate the strength of the magnet, I'm going to take and put a ferromagnetic material, some scissors, near the magnet, and you can see that right away there's an interaction there, that they're drawn towards each other, and the magnet's quite strong. So a really strong magnet is not attracted to aluminum. But here's the interesting thing. When we move an aluminum can near the magnet, we start seeing that an interaction takes place. The magnet starts moving back and forth as we continually move that aluminum can by it. So there's some interaction that's happening here. It's possible that just moving the can caused the air to move, and that moving air is what made the magnet start to move. So we're going to take this Elmer's glue here, and you can see as we move it back and forth, there's a little bit of movement, but it's nothing like we saw when we had that aluminum can moving near the magnet. So the motion of the aluminum can somehow is causing the interaction between it and the magnet. Instead of moving the can, we can actually just move the magnet. So here's the magnet swings. You can see again that interaction. So whether the can's moving or the magnet's moving, either way, or both, we end up having an interaction between the aluminum can, which isn't magnetic, and the magnet. And we can check again to see if the wind was causing the movement. We see a little movement again, but really not very much. At this point, we know that aluminum's not magnetic, but if we have a magnet moving near aluminum, or the aluminum moving near a magnet, there will be some interaction. Part of that interaction is because the movement is causing electrical currents to flow in the can. An example of these electrical currents forming is in the shake light. We shake the light back and forth, you can see the magnet moving, and it's moving through a coil of copper wire. Copper wire is not magnetic. As it moves through that copper wire, it's forming electrical currents, just like we had forming in our can. We store those electrical currents in these batteries, and then we can use the shake light later to generate light when we might need it. So we know aluminum's not magnetic, and when we have aluminum moving near a magnet or a magnet near aluminum, we create electrical fields. Whenever we create an electrical field, it also creates a magnetic field. So here we have a nail, and it's got a copper wire wrapped around it, and one end is connected to the battery, the other end's not yet connected. So we're going to take and sprinkle some iron filings right on top of the paper here, and we really don't see much happening. There might be a little bit of a pattern from when I magnetized the nail a bit earlier, but not much. Now, if we were to take and connect that magnet to the battery, electricity will flow. And you can see, as soon as electricity starts flowing, that we form a magnetic field. And you can see the two poles very clearly on that nail underneath there. So when we have electricity flowing, we generate a magnetic field. Let's take a look at this one more time. The circuit is completed, so electricity is flowing, and I'm sprinkling the iron filings on, and you can see those magnetic force lines being resolved there. When we have electricity flowing, we're going to have magnetism. So let's recap. We have a magnet moving near our aluminum can, and that's causing electrical currents to form. When those electrical currents form, we generate a magnetic field. So looking at our can, we have a magnet moving, but then we have a magnetic field around the can. And that's just like having two magnets next to each other. And when you have two magnets next to each other, they're going to interact. And that's why we see the can move. Let's take a look at Lenz's law in a little different context. We're going to take a thick aluminum tube, and we're going to drop a really strong magnet down it. When that magnet falls down the tube, we're going to be creating electricity and a magnetic field. So watch what happens. I'll start by dropping a quarter down the tube just to show you how quickly it falls. And now the magnet. So the magnet creates that electricity, and it creates that magnetic field that slows the fall of the spherical magnet. It's called the Lenz effect. I hope you enjoyed this video. This is Dr. B, and thanks for watching.